Let's go with me first, and then we'll get that out of the way to let you know kind of who I am. This is my family. This is Ollie, he's in 4th grade. Huge chess fan. Hazel's a kindergartner. She wants to be a scientist because all of her favorite people are scientists. And then this is my wife. She's actually here. And that tells you how frequently I get up in front of people to speak, that she drove up from Atlanta so she could see it. But she is a family's pastor at our church and also really getting into pottery, which works out well for me because we have a lot of really cool stuff coming into the house. So we are based out of Atlanta. We've been there since 2019, but before that, I actually went to Carolina Code School here in Greenville. Before that though, I did a lot of stuff. I think I counted it up and I worked like 15 jobs before. It was, I just kind of dipped in and out of different things, from managing restaurants, working in restaurants, serving. I worked in every part of a restaurant. I worked in a wood shop. I worked in grocery stores. Basically, if I wasn't taking a pay cut and I got to go somewhere else and learn something new, I was gonna do it. And that's just kind of who I've been my whole life, and that's why I actually love this conference specifically. I like to dip in and out of things, just like everyone here. That's why you came to a polyglot conference. So, thank you, Barry, for putting this on. Thank you, Joel, for starting it. Yeah, everyone pour one out. But anyways, getting into the actual meat of what we're talking about here. I'm a senior software engineer at Snap Mobile. And we are pretty good at what we do. It's a fundraising platform for students, and they're like team sports and clubs and whatever they need money for, we want to help them raise it. And this year we've helped students get $80 million with 1 million unique donations. And the reason I mention that is because every single one of those donations has dipped in and out of Temporal at least twice, depending on what it is. So I don't have any relationship with Temporal, I'm just a big fan. It's helped my workload. And so we're gonna talk about it and how it's kind of kept me from having to write as much code. And that's the dream, right? Like less code, less bugs, that whole, that whole paradigm. First, I wanna set a baseline though. Most people in this room, you guys have developed software longer than me. You know more than me. Like, I'm not super concerned about that, but I do want to catch people up who haven't been and just talk about what software was, kind of where it is now, for the most part, and the problems that solved, problems that introduced, and how Temporal kind of helps that. So I'm gonna go quickly through this because last night after the happy hour, I decided that I wanted to do a code example. So we're gonna fly through this part. So, yeah, we'll see. I will keep it tight, that's the guarantee. So, not necessarily at first, but there was a monolith kind of paradigm for software where all of your application was a single unified application where everything was tightly coupled and existed together. So the UI, business logic, database, all of that was just tightly coupled, and the execution path was linear. So it was very straightforward on how to handle retries and things like that. It's client talks to server, that fails, go back to client. Tell them what's wrong. Client goes to server, goes to database, that goes wrong, go back. So it's straightforward to kind of deal with at first, but then as you start to scale up, it's hard to maintain. Now, I'm not debating monoliths, distributed systems, all that good stuff. That's people way smarter than me or fans of both. So, but now, we have distributed systems, and now being relative to then, where everything, like you have these smaller components, which in a lot of cases now it's these microservices. They run on separate machines, they have different data stores, they have different locations, and it's kind of this division of labor where everything is hopefully working harmoniously to solve the problem, right? The shift it just made things more scalable, agile. People could focus on their specific task, their specific team, and just get features out faster is the idea, with less probability for failure. And that does introduce a lot of problems, and we're going to talk about that. So this is kind of a very simplistic view of modern applications and how they handle something like processing an order. So you have this kind of clear sequence of steps where processing an order is the workflow, and what it means to process an order are these 4 different executables, these smaller actions or activities, we'll get to that, in there. And everything kind of handles itself, and you move through it, and you hopefully get the job done, right? It looks very straightforward, really no problems seen until you see it actually in production, where now we have to manage state throughout the whole workflow of processing an order. We have to set up queues and retries, dead letter handling, cron jobs, timers. Like, there's so many things that you have to kind of keep track of now. And you have to do it with custom code in a lot of cases. Like, that's the problem this is solving. Then we go even further, and we know that this is actually not what it looks like when things are moving in production. It looks more like this in a lot of cases, where everything fails, or everything has a probability of failing. I won't, I hope none of your stuff fails. You guys probably write better code than me, that's fine. Everything has a probability of failing, and you need to know how to handle these failures. So you have even small things like a connection limit to a database, or a queue overflow, or just a network failure. Anything like that, you have to know how to react to that. And so that makes it to where you're writing custom retry logic, custom error handling, custom, compensating transactions even. Like, it makes it very difficult to maintain as you start to scale it. So we actually have a more difficult problem to solve now, or a less simple, at least. So when you start out with a distributed system, you have this velocity because everyone's siloed into teams, they own their product, they're moving quickly. But then, as the complexity increases, developer productivity, feature velocity, system reliability, end-to-end insight, all of that decreases, and every product owner's favorite word, scope creep, comes in. And all of a sudden, this project that was supposed to take a quarter is now going out to 6 months, 7 months, whatever. We at Snap are solving some of the problems with Temporal. And Temporal is a reliable open source is key workflow orchestration engine. And it helps you scale and build these complex, kind of long-running workflows in your distributed system. So just by the nature of your code being executed on the Temporal service, you have at a base level state management, default retries, default fault tolerance, and all of this stuff that can be, you can change it up. You can configure what you want the retries to look like and things like that. But just by the nature of it running on the service, it has a baseline to where you focus on, instead of focusing on the infrastructure concerns, you get to write the fun stuff, or at least the thing your PM cares about. It may not be fun, but a couple things about Temporal. These are officially supported SDKs in all of these languages, so Python, Go, .NET, Java, TypeScript, PHP. We also have a Rails application, and it is open source. So Coinbase has actually made an SDK, and we use theirs. So there are others. There are probably more. That's just the scope of what I know. The two co-founders, they actually worked for Uber, working on Cadence, which is their internal event workflow orchestration system. So they know, a little bit about that. But the big idea is that we want to make simple and durable code execution. That's the hope, right? We want to spend less time writing this stuff to where we can have more time writing features and having more joy in our job, hopefully. That's the hope. So let's talk about some core concepts. A few people have talked about explaining technical things in like analogous terms to help understand. So we're gonna carry that over into this, and we're gonna talk about the components like they're parts of a film set. So hopefully it'll stick a little more than just me saying stuff. So the temporal service is like the director. Basically, this is the director of the film who is going to make sure everyone is in their place and everyone knows exactly what to do and when to do it. It manages the state, handles the retries. You can set up schedules, cron jobs, it's like they're a little clean. I don't know if they're cleaner, but anyways, that's the idea. They have internal schedules, and it's going to handle all of that for you to where you don't have to write this stuff. You're just setting up these configs essentially within your code. And all of that comes out of the box. Then we're going to focus on the actors. These are your workers. So the workers and task queues. Basically, the worker is what is actually going to execute the tasks that the temporal service has queued up. The worker will, or these tasks are placed into task queues by the service, and then workers will poll that service and say, hey, do you got a job for me? I really need a job. I would love it if you could hook me up. And if it does, it will dequeue that task, execute that task, go back and report the response to the service, update the state, and then move on. The beauty here is that it's decoupling the execution of tasks from the workflow logic. So that means that you need more throughput, add more workers. That's all you do. You need less, bring them down. And one worker in a task queue can execute like 100 tasks in parallel or something. So you won't even need more than one for a while probably. But anyways, with that, we'll get into workflows and activities. This is kind of the heart here. The workflows, those are the script. They're going to define the process that needs to be followed. So this is what it means to process an order, or this is the script, and we need to complete the full script before we can wrap the movie, right? This is our high-level blueprint. I do want to talk about what long running actually means. Like when you hear it, you think that it is running for a long time. All that means is that it just doesn't have a built-in inherent time limit. So that can be processing an order, but that can also be a long, like an actual long time running workflow that is running indefinitely and charges the right people their subscription fee every day, like that kind of thing. Like you can set up these workflows to handle all of those things. Now, the workflows are designed to be idempotent, and that coupled with the service persisting state, if a system, external system goes down on one of your short-lived processes, those things coupled together makes it to where when it does the retry, it's going to pick up exactly where it left off, and it's going to execute deterministically the point of failure and after. You're not going to have to, you don't have to do really anything. And we'll show an example of that when we get to the example of where we're going to fail an activity and then show that the previous activities aren't run again. But the workflow itself has to be idempotent for this to actually be possible. They can be simple or they can be complex. What we're going to look at, very simple. It's the process order. We're gonna make that real. But they can also have, divergent logic where they run in parallel with each other. They could have child workflows, things like that. Then the activities, these are going to be the scenes. These are the individual shots we need to get to complete the overall goal and push the goal forward. So an activity is something like calling a third-party API or generating a report, things that are messy. Like messy stuff goes in an activity. Anything that is faulty goes in an activity. These are decoupled from workflows entirely, which means that you're playing with Legos. Like it's this activity from this workflow. Well, it's not even from a workflow, it just is executed in a workflow. But this activity can work in these 3 workflows. You just have to plug it into what it means. And what I mean by that is using this system where we have a third-party API activity, calling to a third-party API, generating a report, and sending an email. That is a workflow where you're generating a sales report for the CEO, right? Like that's what that means. That's the workflow. Tell CEO about salespeople, whatever, You take that send email and you plug it in to a different workflow where you get an alert if some parameter is met on workflow failures even, or the activity failures. You can plug these, move them around to where it makes it to where your code is maintainable, scalable. It's similar to modular code. It's not groundbreaking, but I'm just telling you what it is. One of the key benefits of using temporal activities for the faulty tasks is that it's going to handle this stuff for you to where you don't have to write this stuff. And we're gonna look at that because we're gonna look at some other cool features first. I don't have these in my example, so I wanted to build them in here, or talk about them here. There are these things called signals where you can inject real-time inputs into your long-running workflows, and that'll change the behavior of that workflow on the fly to where you can, if you need to cancel like processing an order, updating a status or something like that, you can do that by calling out and just pushing that signal in. There are also these queries that you can set up, these internal queries, where, you can ask the workflow about the workflow, right? Like you can and that's great for if you have a long-running workflow that it needs something more visual, like some kind of display representation for product or whoever. You would query into that, or you would create a query in your workflow and then get into the workflow, pull the query, and then use that to display your data, just like you would pull in from a database. They're child workflows. They break down these complex processes into smaller workflows, very similar to activities. You can just kind of move around, plug them in. But it works out for the example of onboarding a new employee. Depending on what type of employee you are, that looks different for you as a full-time employee, someone else as a contract employee, things like that. You have different steps that comprise the onboarding process, and they may need to be broken down into child workflows. Like one workflow would be a workflow of compliance training, a workflow of distributing IT, resources, doing payroll, things like that. And you may not distribute IT resources to contractors. Who knows? Whatever your company does. But that's an example of when you would use child workflows. And then this is one of my favorite things, the temporal UI. Just by virtue of running a temporal server, you have access to the UI where you get insight into workflows and activities and all that run on your temporal service. And we're actually going to look at that now with some bonus nachos here. So everyone loves a code example. This is going to be like, this is a typical workflow pattern This is about as close to pseudocode as you can get and actually still function. So don't, this is just to show things that you have to keep up with if you're writing this stuff yourself. So you're going to be keeping up with, so we have this class here of process order workflow. And throughout this whole process, we are going to be keeping up with the state. We're going to be handling our own retries. We have workflow failures that we're checking on. I'm going to speed this part up, but this isn't the fun part, so I don't want to focus too much on this. And I don't want you to focus too much on my code here too. But anyways, so to do this, once you get to a certain point, you're updating the current step. You're wrapping your functions with your retry, that's at the bottom, with your retry function that will say, if you get a failure, retry X times, whatever. But you're doing all of this manually to where even on something simple like this, I'm scrolling and it's not optimized, whatever. I'm not super concerned about that, but the point is it gets a little messy already. Then we're going to, before I get into that, I have 4 files up here, a client and a worker. Those we don't need to actually talk about too much, but the workflows and activities, workflows specifically, are the important part. Actually, let's just go to that. That seems more like a fun. So this is the process order workflow of kind of a typical setup. And then this is your workflow setup with Temporal. It is 40, less than 50 lines. And it's doing all of the same stuff that the previous slide did, but arguably better. Not arguably, in this instance, it's better. So we have here this process order workflow, and all I'm doing is, because this code is going to end up being executed on this activity, our prepare shipment activity or function, and there's a process payment, update inventory. These are all going to be executed as activities through the temporal service. I didn't write any retries. I didn't write, well, you do see at the top, you can have, there's a retry policy and you can kind of adjust it. I changed the max attempts to 3 so we can hopefully speed through this a little bit. But anyways, you cut down on the custom logic that you're having to do. And then the activities, just so you can see behind the curtain a little bit, all this is doing, checking fraud has a 90% chance of passing. This update inventory will fail 2 times, just so we can look at that. Processing a payment has a 40% chance of success. We get down here, this is just gonna happen. And then the log to dead letter queue is nothing. But it's just to show how easy it would be to hook into that functionality. The others, the activities for the normal workflow pattern, they do the same exact thing. They're all the same. So let's get into what this looks like. All right, to get us up and running, let's see. Start the server. And then when you start the server, you have the UI available to you. There are no workflows or workers running right now, but you can set up schedules here in the UI. I recommend doing it in your code to where it'll, if your server goes down, your schedules don't go down on the next run. But anyways, but you have all of this right out of the box without even running a worker or any workflows through it. But we want to run some stuff. So I'm gonna run this client file, and then we're gonna go back, and you see here, started workflow order 79774. We're gonna just refresh this. And now we see that it's running, and oh man, it should have completed by now. I'm shocked. Oh, there are no workers. I wanna show, let's get into that. So that has already been put into the service, and it's just sitting there waiting for a worker that can pull tasks from that task queue. And then let's see what happens whenever we go back. Well, we could just refresh that. Okay, it's completed now. And I want to make sure that we have a good one to look at. Order flagged as fraudulent. We actually don't want that one. That's fine. Yes, great. Okay, so this next one, let's pop in and see what we have here. So right from the jump, we see we have a history that is 29 items long. Let's go down here and look at that. Do I have it on? I have it on compact. I want to see the history. And we see here, we start with the workflow execution. Then we schedule a workflow task. We're going to move on up a little bit. But we see here, we're pulling out what the input was for that check fraud activity. We see what the result was, and we're not digging through logs. Like these are logs specific to this workflow. So you keep everything tight to where you're not digging through logs to figure out what went wrong, that kind of thing. I gotcha, yeah. Anyways, moving on up here, we have the update inventory. This is actually what I wanted to see here. So this is the one that's going to fail twice. You see, there were 3 attempts to complete it. That's what we want to see. But we do want to make sure that this first one did not execute 3 times, and it did not. So just by virtue of it being there, it picked up on the state when it failed. It picked up exactly where it left off. No muss, no fuss. I got to not write 150 lines of terrible code, and I got to write, 50 lines of okay code. Then we get up here and we see that it logged to the dead letter queue. One thing that's super important for y'all, you see how it completed even though it logged to the dead letter queue. Build your workflow so they complete, even if it's not success. Those are 2 different things. You want it to complete. You don't want these because they end up, that actually works out well. Oh, there we go. Super quick. There are compact views, different views. Input and results gives you a concise look at it if you want. Timeline is awesome. You can see what executed when. So you see that had to retry 3 times, so it took up the bulk of everything, and all these other things are just little blips. You can set back off policies, things like that. It's completely changed how we work. Just because it wouldn't be complete without a thank you, we're going to do that part. And thank you. There are resources here. I will put the slides up. These links do work in the slides. You don't actually have to scan that if you don't want to, if you're not comfortable. I get that too. Yeah, thank you. I would love to talk more about this with anyone. I'm a zealot, completely a zealot.